Hi, I'm going to be solving a non-homogeneous differential equation by the method of undetermined coefficients with the superposition approach. A non-homogeneous differential equation has an input function, g of x. So the general solution is a linear combination of the solution to the homogeneous equation plus the particular solution for the function g of x. The differential equation which I'm going to be solving is y double prime plus 2y prime equals 2x plus 9 minus e to the minus 2x. To begin, we solve the homogeneous equation. Y double prime plus 2y prime equals 0. We must find an auxiliary equation and then solve for the roots. So we write m squared plus 2m equals 0. Factoring to get m times m plus 2. With the roots, m equals 0 and minus 2. We can now input the roots into the solution for the homogeneous equation to give us y of c equals c1 times e to the 0, which is simply 1, plus c2 times e to the minus 2x. Next, we want to find our particular solution. Our function for g of x is composed of two kinds of functions. We have a polynomial and an exponential. So we're going to divide y of p into y of p1 and y of p2 and solve separately. So for g of x1 equals 2x plus 9, we pick a trial solution for y of p1 in the form of a polynomial. Our trial solution is going to be ax plus b. Now we check that the homogeneous solution contains the same functions. If so, we want to multiply y of p1 by x to get unique functions. So we have y of p1 equal to ax squared plus bx. We can now use this to solve for y of p1. We must take the first and second derivatives of y of p1 and plug these into the differential equation. Y of p1 prime equals 2ax plus b, and y of p1 double prime equals 2a. Plugging these into the differential equation gives 2a plus 2 times 2ax plus b equals our function for g1 of x, which is 2x plus 9. Expanding, we get 2a plus 4ax plus 2b equals 2x plus 9. We can now set the coefficients of x equal to solve for a. We can write 4a equals 2 to give us a equals 1/2. Now we set the coefficients of the constant equal to solve for b. So 2a plus 2b equals 9. Plugging in our value for a, we get 2 times 1/2 plus 2b equals 9. Or 1 plus 2b equals 9. 2b equals 8, so b equals 4. We can now plug in our values for a and b into the function for y of p1. To give us the first part of our particular solution, y of p1 equals 1/2 x squared plus 4x. Next we want to find y of p2. Our function for g of x2 is minus e to the minus 2x. So we want to pick a trial solution in the form of an exponential. So we choose y of p2 equals c times e to the minus 2x. Now we check this with our homogeneous solution, and we find that we already have a constant times e to the minus 2x. So to make this a unique function, we multiply y of p2 by x to get cx times e to the minus 2x. We can now take the first and second derivative and plug it into the differential equation to solve for c. So y of p2 prime equals minus 2c x e to the minus 2x plus c times e to the minus 2x. And our y of p2 double prime equals 4cx e to the minus 2x minus 2c e to the minus 2x minus 2 times c times e to the minus 2x. We can now plug in the first and second derivatives into our differential equation to solve for c. This gives us 4cx e to the minus 2x minus 2c e to the minus 2x minus 2c e to the minus 2x plus 2 times minus 2cx e to the minus 2x plus c e to the minus 2x equals our function for g of x2, which is minus e to the minus 2x. Expanding, we get 4cx e to the minus 2x minus 2c e to the minus 2x minus 2c e to the minus 2x minus 4cx e to the minus 2x plus 2c e to the minus 2x. We can see that 4cx e to the minus 2x cancels with a negative 4cx e to the minus 2x, and a minus 2c e to the minus 2x cancels with a positive 2c e to the minus 2x. So this leaves minus 2c e to the minus 2x equals minus e to the minus 2x. We can now compare the coefficients of the exponential to solve for c. This gives us minus 2c equals minus 1. So c equals 1/2. Plugging in our value for c into y of p2, we get y of p2 equals 1/2 x e to the minus 2x. We can now write our general solution. The superposition principle says that y of p is equal to y of p1 plus y of p2. And so adding the solution to the homogeneous equation to y of p1 plus y of p2 gives us the general solution to the non-homogeneous equation. So our final solution will be y of x equals c1 plus c2 e to the minus 2x plus 1/2 x squared plus 4x plus 1/2 x times e to the minus 2x. Thank you.